Let's talk about the unsung heroes in your medicine cabinet. Today, we're diving into glidants. You know, the invisible force that makes sure just about every tablet you've ever seen is made, well, perfectly. I mean, really think about it for a second. These high-speed factories are cranking out millions of tablets, and every single one has to have the exact same weight and dose. How on earth is that even possible? Well, the answer comes down to solving one huge challenge. And to get the solution, you've got to understand the problem first. For tablet makers, the absolute number one enemy is something called poor powder flow. Just picture this. You're trying to pour something that's way stickier than sand, a powder made of all these tiny, weirdly shaped particles through a super small funnel, thousands of times a minute. It's a recipe for disaster, right? Without some help, you get these microscopic traffic jams. The particles just clump up, they stick together, and they absolutely refuse to move smoothly. And these little traffic jams, they have huge consequences. We're talking uneven pill weights, which means wrong dosages. We're talking ingredients that don't mix right, and we're talking about jamming up multi-million-dollar machines. So for the folks making these tablets, solving this flow problem isn't just, important, it's everything. So how in the world do you get a sticky, clumpy powder to flow like water? Well, that's when you call in the heroes of our story, glidants. Okay, so what is a glidant? It's what's called an excipient. And you can just think of excipients as all the other stuff in a pill besides the actual drug. They're there to help make it or keep it stable. And a glidant, it has one job, and one job only, to cut down on friction and cohesion. Those are the two forces that make powder particles want to stick to each other. So how do they pull this off? It's pretty cool, actually. Think of glidant particles like microscopic ball bearings. Yeah, seriously. They get in there and they coat the bigger, clunkier drug particles, smoothing out all their rough edges. This slashes the friction, stops them from clinging to each other, and just unleashes this perfect, consistent flow right into the tablet mold. And here's the part that's going to blow your mind. You don't need a lot of this stuff. We're talking a concentration as low as 0.1%. That's it. That tiny amount is enough to completely transform a clumpy mess into a beautiful, free-flowing stream. That is an absolutely incredible amount of impact from such a teeny tiny amount of material. Okay, so what are these magical ingredients? Well, there are a few out there, but the world of tablet making is really dominated by two major all-stars. All right, in one corner, we have colloidal silicon dioxide. You can think of this one as the microscopic sponge. Its particles are unbelievably tiny and have a massive surface area, which is just perfect for coating other particles and sucking up any extra moisture. And in the other corner, we've got talc, the smooth operator. Its particles are shaped like little flat plates that just slide right over each other, kind of like a deck of cards. This makes it amazing at stopping powders from sticking to the machine. Now, to be fair, these two aren't completely alone on the team. You've got other things like starch or certain types of cellulose that can give a little bit of flow improvement. And yeah, lubricants like magnesium stearate can sometimes lend a hand. But really, they're the supporting cast. The real heavy lifting is almost always done by our two all-stars. So let's put ourselves in the shoes of a pharmaceutical scientist, a formulator. How do you decide which glidant to pick, or even if you should use one in the first place? It's not just an automatic thing, it's a really strategic choice. And that whole decision process is a real balancing act. On one hand, yeah, glidants are absolutely essential for those sticky powders or when you're using super high-speed machines. But on the other hand, if your blend already flows great, well, adding a glidant is just adding complexity you don't need. And you've got to be careful, too. Too much talc, for example, repels water, which might stop the tablet from dissolving the way it should. Overdo it with any glidant, and you could actually make the final tablet weaker. It's all about finding that perfect sweet spot. And hey, here's a cool little insider tip, straight from the manufacturing floor. Glidants, a lot like lubricants, are usually added at the very, very end of the blending process. Why? Because that makes sure they coat the outside of the little powder clumps instead of getting buried deep inside them. This way, you get the maximum ball-bearing effect right where you need it most. Okay, so we've gone through all this. Why should any of us really care about these tiny, invisible powders? What's the big takeaway here? It's simple, really. Glidants are the gatekeepers of quality. By solving that fundamental problem, that traffic jam of powder, they're the reason every single tablet that rolls off the line has the exact right amount of medicine. They ensure it's going to work the way it's supposed to and that it's free from defects. They're a direct link to the safety and the reliability of the medicines we all depend on.
Because at the end of the day, making a perfect tablet isn't about finding one single magic ingredient. It's a whole strategy. It's about understanding how all these different things, particle size, machine speed, and yeah, these clever little excipients like glidants, all have to work together. It's like a carefully choreographed dance, all to create that one high-quality, reliable product. So the next time you pick up a simple pill, just take a second. Remember the incredible science that's packed inside. Remember those microscopic traffic jams and the tiny little ball bearings that are in there solving the problem. And then ask yourself, could a little bit of invisible powder, a glidant, be the true unsung hero in your medicine cabinet?